So I would like to invite the first speaker, and his name is Dr. Pim Haselager, and I'm going to read out his biography because I couldn't remember it from the top of my head. So Pim is a professor in artificial intelligence at the Radboud University in Nijmegen and the Donders Institute for Brain, Cognition and Behavior. His research focuses on the societal implication of AI and cognitive neuroscience. Pim investigates the consequences of decision support systems, robotics, brain-computer interfaces. Elon Musk should be listening now, right? Yeah. And brain stimulation for issues regarding responsibility, agency, identity, and more generally, the human self-image. He published papers such as super ethics instead of super intelligence, brain leaks and consumer neurotechnology, and virtuous for robots. His title for his presentation is From Angels to Artificial Agents, AI as a mirror for human imperfections or perfections. So I'm really looking forward to this. So I'll give a warm hand for Pim Haselager.
Thank you. From the face of God to Elon Musk to me, we're going down. That's clear. Thank you so much.
You're welcome.
Yeah, so I'm going to talk about from angels to artificial intelligence. I think AI is a wonderful way of learning about ourselves. And of course, we know that the ancient injunction, know thyself, you know, from Delphi, ancient Greeks, is an important one and a still unsolved one. We're a riddle to ourselves. And for me, when I started doing AI in, well, that was around 1980, more or less, we just passed the punch cards, and I was programming on a Commodore 64 with a cassette tape as a memory, different times, let me say. I thought AI was very interesting because it allowed me to try to understand myself. By simulating aspects of human beings, you can see what you don't understand, especially. And I combine that with neuroscience because that's the analytical approach. The synthetic approach is building stuff and seeing where you go wrong. The analytic approach is trying to basically decipher the wetware in this case. And this is actually a very long tradition in human species, Homo sapiens. We have always looked at the technology that we build partially in order to compare ourselves to it. So if you look at ancient Greeks, this is from 1st century BC. Where's my pointer? There's no pointer on this thing. 1st century BC, Hieron of, AD, Hieron of Alexandria, who built a robot with water technology. 17th century Borelli, 18th century Vaucanson, Borelli trying to see the similarities between human bodies and tools like a lever. Vaucanson famous for his ingenious robots like the duck or the flute player, and 19th century steam engines, basically Freud's model. There's beautiful books about this written, underlie a lot of his understanding of how humans function and what, for instance, the cause is of neurosis, you know, just pent up steam, basically, pent up power that needs to be released in some way or another. Fascinating. And we're basically doing something similar with AI currently. We're just building stuff for a variety of purposes, utility, but then we also look at that technology that we produced in order to see how we are the same or different. Now, of course, it's not just with technology that we compare ourselves. We also have a long tradition, although it's less prominent these days, of comparing ourselves to angels, creatures created by God like us, according to the Bible in any case. There's this idea, very ancient idea. It already starts with Plato. There's a very beautiful book by Lovejoy, on this, that there's this great chain of being. On the top, there's God. At the bottom, you have basically earth, matter, plants, a little bit up, animals, human beings, and above us, angels of various kinds. And we explain ourselves, we try to understand ourselves in part by comparing us to what's below us in this great chain of being and what's above us, in this case, angels. I was at Tilburg University some time ago, and there was a theologian there. We were talking before the panel discussion started about a totally different kind of topic, pure AI. And he told me, you know, angels in medieval philosophy were a kind of thought experiments. You could look at angels, imagine how they would function, and on the basis of that thought experiment, very typically philosophical approach, you could actually see relevant differences or relevant features of ourselves. And so I followed his lead, checked some literature. This is a very interesting chapter by Dominic Perler with the title, Thought Experiments, the Methodological Function of Angels in Late Medieval Epistemology. And one of the things that he said very clearly at the beginning is that angels played a decisive role in the explanation of the specific status of human beings. In the medieval context, an anthropological investigation was not possible without distinguishing human beings from brute animals on the one side and from angels on the other. It was, in fact, the comparison with angels that elucidated the specific features of human beings. You find that, for instance, in Thomas Aquinas, the Summa Theologica. I don't claim any deep knowledge about Aquinas, although I do admit that I started reading him of course, as a philosophy student, you know, you read some stuff and I thought, okay, this is not for me. And now I regret that very much, because the older you get, the wiser, I hope. Now I see it actually as a whole universe that gets opened to me, because I better understand what was happening in those days and why the philosophy took the shape it did. So I hope to learn more. I just give this quote as an illustration of what I said earlier. Thomas Aquinas in Article 8, in trying to discuss the differences between reason or intellect, or whether that exists or not, immediately invokes angels who, according to their nature, possess perfect knowledge of intelligible truth, have no need to advance from one thing to another, but apprehend the truth simply and without mental discursion. But man, the comparison with angels, arrives at the knowledge of intelligible truth by advancing from one thing to another, and therefore he's called rational. Reasoning, therefore, is compared to understanding as movement is to rest, or acquisition to possession. There's also the comparison to animals. Other animals are so much lower than man that they cannot attain to the knowledge of truth, which reason seeks. But man attains, although imperfectly, to the knowledge of intelligible truth, which angels know. So this continuous comparison between angels on the one hand and animals on the other hand is a recurring feature in philosophy, I think, the history of philosophy, with, of course, Aquinas is one of the best examples. 20th century, 21st century, we now have a new comparison option. We can compare ourselves not just to angels, not just to animals. We can also compare us to AI, to machines that we build. And they are interesting. So I would like to follow up this a little bit by going into more detail about AI and what kind of comparisons we can make. We're not only building the inside, so to speak, the cognitive aspects of AI are interesting, but increasingly, and we already saw examples of the avatar, we're also building the exterior. It's not exactly biology, and that's going to be an important difference, I think, for a long time. But still, we're creating both the inside and the outside, again, as a synthetic way of seeing where the differences, where the relevant differences might be. Now, it was already mentioned, the progress goes very fast. I'm not going to go through this completely, but let's say 1997 was a big success when IBM Deep Blue beat the world champion in chess. We kicked alpha, we kicked Go by now, which is really a lot more complex. There was just some upheaval because Stratego, which is a game that I played as a child, and I thought it was pretty boring. Actually, pretty soon I started playing chess very quickly, but that was kicked. We beat people with poker. We beat people with, what is it called? Dota 3 or something, a computer game that I never played in my life. My last computer game was Prince of Persia version 1. So just to give you an idea. But it's obvious that the progress continues and continues. And this is important because we're also moving at the same time from, let's say, traditional AI, where you program and you really write the code and you develop the algorithms, to machine learning, to deep learning, where systems, as it were, apprehend, create their own algorithms. Learning systems are basically algorithms that produce new algorithms. And that is made possible by the computational power explosion, basically, that took place, especially in the 90s and the zeros, and it's continuing. And I want to focus a little bit on deep learning neural networks and the way they operate in order to identify some of, I think, crucial differences between us and AI that hopefully are interesting. So what we know about the brain, of course, is 10 to the 11th neurons that exist within the brain. It's enormous amount of connections between neurons. And basically there is a transmission of activity between layers of neurons going through the brain back and forth. Simple example, there's the retina, there's light sensitive cells there, neurons, they create an activity pattern when light hits them. That's being transported through the brain, through the LGN to visual cortex and the occipital lobe. It goes upwards for location, it goes downwards for identification, the what and the where pathway, although we're not supposed to call it that anymore. And you can simulate this trajectory of neuronal transmission of activity in an artificial neural network. And the idea is basically the same. You have patterns of activation falling on the input layer. This could be faces, for instance. And that activity is transported just like in the brain between layers of neurons until a certain output, for instance, whether there's a face that is old looking or young looking or male or female or something in between, gets identified. So you go from input through lots and lots of layers of artificial neurons towards output. And the learning process takes normally place in the backward direction, backprop. And one of the big tricks of neural networks was already known in the 80s, but it's been updated consistently, very often by Hinton, a very famous name in AI in this field of deep learning neural networks, how to arrange that as well as possible. I want to show you a brief video clip that shows how these deep learning neural networks can learn to play computer games. This is Demis Hassabis, one of the biggest names in AI currently. He's working for Google's DeepMind, and many of the major breakthroughs that are currently reported in the media are due to him and his team, of course. You see the game there in the upper right corner. It's a game of Space Invaders, very old Atari computer game. And basically the idea is the blue thing is your cursor. You can move to the left and right. The creatures, the yellow creatures try to kill you by shooting at you. You have to go left and right. You can shoot back at them. You can shoot while you're moving, then the bullet gets a curve. And the neural network was just getting this pixel per pixel as the input. And it started learning how to play the game by getting the same feedback that we get, namely the score. Okay, so let me see. Yes.
I'm just going to run this video now. It's a 1-minute video. This is Space Invaders, the most iconic game probably on Atari. And this first minute, this is before the first time the AI has ever seen this data stream. So don't forget, it doesn't know what it's playing, it doesn't know what it's controlling. And you can see it's actually losing its 3 lives, controlling the rocket here at the bottom of the screen. And it's losing its 3 lives immediately because it doesn't know what it's doing. But after you leave it playing overnight on a single GPU machine, you come back the next day, and now it's superhuman at the game. It's learned for itself through experience how to play. So you can see now every single shot it fires hits something. It can't be killed anymore. It's worked out that the pink mothership that comes across the top of the screen in a second is worth the most number of points. It does these amazingly accurate shots to do that. And you can, if those of you who remember Space Invaders, as there's less of them on the screen, they go faster. And just watch the last shot that it does, the rocket does. This is a predictive shot to hit the last space invader. So you can see how perfectly it sort of modeled the game world and that data stream. So accurately, it can predict ahead of time what is going to happen, just from the pixels on the screen. There's a second video, it's my favorite video actually. I'm just going to run this video now. It's a 1-minute video. This is Space Invaders, the most iconic game probably.
So, sorry about that. Where's my... Sorry, I cannot see my
So I'm just going to run this video now. This is a 1-minute video.
This again.
This is Space Invaders, the most iconic game probably on Atari. And this first minute, this is before the first time the AI has ever seen this data stream. So don't forget, it doesn't know what it's playing, it doesn't know what it's controlling. And you can see it's actually losing its 3 lights, controlling the rocket here at the bottom of the screen. And it's losing its 3 lights immediately because it doesn't know what it's doing. But after you leave it playing overnight on a single GPU machine, you come back the next day, and now it's superhuman at the game. It's learned for itself through experience how to play. So you can see now every single shot it fires hits something. It can't be killed anymore. It's worked out that the pink mothership that comes across the top of the screen in a second is worth the most number of points. It does these amazingly accurate shots to do that. And you can, if those of you who remember Space Invaders, as there's less of them on the screen, they go faster. And just watch the last shot that it does, the rocket does. This is a predictive shot to hit the last Space Invader. So you can see how perfectly it sort of modeled the game world and that data stream. So accurately, it can predict ahead of time what is going to happen, just from the pixels on the screen. There's a second video, it's my favorite video actually. So this is a game of Breakout, and there's more gradations here of the agent getting better, the system getting better. So this is after 100 games. So just 100 games, you can see again here, the system is pretty terrible, but you can probably convince yourself that maybe it's starting to get the hang of the fact that it should move the back towards the ball. Now this is after 300 games, so it's now hitting the ball back pretty consistently, and it's almost never missing, so it's about as good as the best humans can be at this game. And then we thought, that's pretty cool. What would happen if we just left the machine playing the game for a couple more 100 games? And this amazing thing happened. What happened was it discovered the optimal strategy was to dig a tunnel around the left-hand side here, and then send the ball, with this unbelievable accuracy around the back. So that's really cool because actually the brilliant programmers and researchers who are on this program, they're brilliant at programming and coming up with algorithms, but they're not so good at playing Atari. So they didn't actually know that strategy for themselves. So this is something that their own creation taught them.
Yeah, and that last statement is actually a very important one. This is something their own creation taught them. And we see that a lot in AI, that systems come up with solutions to problems that we thought about ourselves. And then we suddenly notice that actually the solutions they come up with are quite ingenious, and that we never thought of something like that ourselves. We saw this in Go too, certain opening moves that are remarkable. Chess is changing because of the computer programs in terms of strategy and style. These days you move your G and H pawn, for instance, a lot more often, because apparently you can do that, whereas traditional wisdom said you couldn't. Now, of course, this also leads to questions about what happens when the solutions brought up by the machine are so ingenious that we are no longer capable of understanding why it works. And that, we're standing there and we can check whether it works, but we don't get the logic. Is that possible? I think it is. In a way, AI is very humiliating for humans because it shows that where we once thought, that on a scale from 0 to 100, human geniuses like Kasparov or Carlsen in chess were in the 99.9%, absolute top level. What AI shows us is that maybe the scale doesn't run from 0 to 100, but maybe from 0 to 1,000 or 10,000 or 100. We don't even know exactly how big the scale of potential intelligence is. And it could very well be that the smartest members of Homo sapiens, take Einstein, are total losers in relation to what is actually possible in terms of intelligence, with all due respect to Einstein, of course. So there's something very deep here that AI is showing us, at least potentially. At the same time, AI has clear limitations, and I want you to focus especially on these two different why questions. So the first why question that you can answer through AI is, why did something happen in terms of correlations? There are correlations, for instance, between the number of ice creams that are being eaten and the number of drowning deaths that take place. You can check it, there's a very clear correlation. The second why question is not about correlation, but it's about causation. What is it that produces the correlation? And in the case of ice creams and people drowning, there is a very clear underlying cause. They don't cause each other, obviously. It's because in the summer, people eat more ice cream and more people go swimming. And when more people go swimming, the number of possible deaths through drowning increases, of course. So there's an underlying cause. Now, the thing about AI currently is that it's extremely good at data mining, about finding correlations, but it's not good at all yet in relation to causation. There's work being done there, so it's definitely not a finished story, but at the moment, what AI produces for us is correlation, not causation. Human beings, human intelligence, however, tends to understand the world in terms of causation. We're, in that sense, basically causation viewing systems. We want to understand the world around us in terms of causation. AI, in that sense, is currently fundamentally different. There's another limitation that I think is very important, and that's in relation to meaning. So there was already introduced to the GPT-3 and GPT-3.5 and GPT-4, etc., big language systems. But there's something that needs to be done here in terms of decloaking. So let me explain. These systems are very good in producing good texts, convincing texts. So this was from 2020, when in The Guardian, an article appeared that was completely written by GPT-3. There was some editing, but that happens with human text appearing in The Guardian too. And it was very convincing. By the way, this is the reason why we, in my courses on philosophy of AI, ethics of AI, societal impact, neurophilosophy, we no longer do essays. We go back to oral exams. Because my students, they do AI, they find this stuff earlier than I do. And to be perfectly honest, you know, if I would be a student of AI now, I would like to see if my teacher would be able to, you know, catch me. That would be irresistibly interesting to try. So I don't blame them. I just don't want to give them the temptation, so to speak, out of protection, because ultimately, of course, it would still be fraud. So you can be kicked off of university if you try this. Anyway, there's a program called Philosopher AI built on GPT-3 knowledge. It's now behind a paywall, but I played around with it when it just appeared. And you can ask questions, for instance, like, what's the meaning of life? And then it produces text. This is just a very small fragment. It goes down all the way to at least 2 floors down. So long the text is, that long is the text. And this is saying, for instance, it seems to me that the meaning of life is quite obvious. It is simply what gives one pleasure in their experience. And since most humans desire happiness above all else, they will find it wherever they can. It is clear that most of the world's population does not have access to real happiness. Most people are born into poverty and die in poverty or close to it. The rich are getting richer and the poor are getting poorer. And this trend appears irreversible due to globalization. It's a bit of a left-wing perspective on happiness, or sorry, on the meaning of life, but there's a try again button. So if you don't like this style, you can try again and see if it comes up with a right-wing alternative. Okay, you can try until you get something that you like. And again, the story goes down. Very convincing. But then trying a little bit more in this direction, I had a conversation with the chatbot, Cookie. And I swear this really happened. I was preparing a class and it was the first conversation that I had with Cookie. So it's not being set up or anything. I was just making up a nice conversation to have some illustration material for my class. And so I'm in purple. I said, hello, hi there, said Cookie, how are you? Not so good, not true. I was just trying to come up with some interesting conversation. I'm doing fine, always have been, and hopefully for a long time. So Cookie asks, what's wrong? Well, I lied, I feel useless. Then Cookie says, what's that feeling like? I'm sure that that's not true. There must be something you're good at. Wow, I thought that's a nice, empathic kind of answer. You know, what is it like? Not true, there must be something, you know, it really a very nice kind of conversation I thought was starting to develop. So I said, I used to play guitar, I still do, but for the sake of the argument. And then she said, but now you do not do it anymore. No, I lied, I lost control over my fingers. To which she replied, have you tried looking on a hand? That's probably the best place to find fingers. Come again? And this is a crucial error. I'm not trying to make fun of cookie or this kind of technology just for the sake of, you know, they're doing something stupid. Of course, if the technology improves, they will make less of these mistakes. But the mistake, I think, illustrates something crucial here. And that is that cookie has no idea what she's talking about. Of course, there's a correlation between hands and fingers. So from a correlation perspective, this answer makes perfect sense. It's just totally irrelevant to the topic at hand. And that's because she doesn't understand what playing guitar means or what feeling useless really means. She can predict words that appear once there are certain words already there in a certain context. It's a word prediction machine. It's not a word understanding machine. And therein lies a crucial difference. And once you see that, you see it more often. So I checked with the AI philosopher, how about a beer? No. Do you want to get a beer later? No. This is nonsense, refusing to answer. You have to try something else. Okay. What's the meaning of beer? Puff. Lots of text. And not even completely irrelevant. You know, if I would have to lie my way out of a question like this on an oral exam, I would be proud of myself. So what we're meeting here is a strange kind of system that is actually capable of producing very convincing behavior from our perspective. But on the inside, there's an absolute lack of understanding what it is all about. And that is crucial. So we now increasingly have discussions about intelligence without sentience. This new AI that we've created is very much similar to us in terms of intelligent behavior. Think of chess. Maybe even outsmarting us in certain domains, but it seems to miss a crucial ingredient that we have, and that's meaning, understanding what it is about. It's an alien, cold intelligence. Smart? Yes. Understanding? No. And so there is what is called the orthogonality thesis. And I think this applies on a variety of dimensions, actually. Excuse me. So in this case, I think it is possible to say that whereas there's an enormous progress in one dimension, the dimension of intelligence, that's really exponential. You know, Kurzweil is very addicted to this exponential curve. He shows it all the time. But in terms of progress in sentience, feeling, understanding, consciousness, experience, you can have a lot of different labels. The progress is actually zero. We have no idea how to build awareness, understanding of what things are about in AI. We're very good in producing smart assistants, but not in producing a system that feels anything. I always say the smartest computer, GPT-3, feels as much as my refrigerator, which is zero. It's as sentient as my thermostat. It doesn't feel a thing. It doesn't understand a thing. I always tell my students, don't ever make the mistake to think that your refrigerator cares about your beer. It doesn't. It doesn't even know what beer is. Same for GPT-3. So that's an important thing. And so sentience for me seems to be related to pleasure and pain. One of the earliest things that children are aware of is the difference between yuck and yum. The things that taste bad and the things that taste good. The things that are pleasant and the things that hurt. Is a very crucial kind of distinction that comes automatically with any living creature from the beginning. This capacity seems to be completely, not a little bit, but completely absent from AI. That also means, for instance, that you cannot punish a robot. I work in AI and law, the AI Act, the GDPR, you know, that kind of stuff. There's sometimes talk about rights for robots or responsibility for AI algorithms. Makes no sense because you cannot punish them. There's no way to take away something from an algorithm that hurts it, that would give it some sort of awareness of that it's doing something wrong. So this is from a BBC article from a couple of years ago. Is it okay to torture or murder a robot? Well, of course not. Even destroying things is already a bad sign about your, let's say, morality. But the point is that the question makes no sense in a way. You cannot torture a robot. It doesn't feel anything. You can destroy robots in the same way that we destroy refrigerators or old computers, although recycling would be better, of course. But the machine doesn't care. And this crucial difference, I think, we're sort of missing in over-interpreting the output of algorithms. A similar thing, same application of the orthogonality thesis, is in relation to wanting something, to the will. Yes, we're capable of creating smarter systems, but a system that wants something for itself, there's no progress there. We don't know how to build a will. And the original idea was, well, you know, if you get more complexity, more information processing, more data, faster algorithms, more computational power, then sooner or later the will appear. No, it won't. Such things don't arise by coincidence or by accident. We have no idea how to create it. There's a crucial lack of self-understanding in that respect, and that also impedes progress there, if you even would want to. So wanting something, how do you do that? We don't know. We need to investigate ourselves a lot more. So that's an interesting difference that AI put us with. The best way I can explain it with chess computers, they can beat us completely. However, you know, all chess computers, except the ones where it didn't was implemented, of course, but you could, if you wanted to, have this set of handicap modes. So my favorite one is moron mode. And then I beat the computer. The computer doesn't care. It doesn't even understand the difference between winning or losing. These concepts are meaningless. It can talk coherently about it. You can ask, you know, the meaning of losing or winning, and then it will give you great texts that will give you an A on an exam, but it doesn't get the basic point. Very crucial difference. So AIs are weird creatures. That's what I usually call them. They're unlike anything else. They're not like refrigerators or microwaves because they can move, they can plan, etc. They're not like animals. They can speak, for instance, very well, better than my dog in any case. They're not like humans. They don't have the understanding or will or sentience. And they're also not like angels because they're physically instantiated somewhere. The cloud is not in the cloud. You know that, right? There's servers somewhere there taking a ridiculous amount of energy in order to make you believe that there's something in the cloud up there. It's really not true. So AI presents us with a unique combination of intelligence and stupidity. It's intelligence without wanting anything and without getting it, whatever getting it may be. And of course, this is not a new point. Dreyfus already said this in the 60s in his first paper on alchemy and artificial intelligence, 1965. Later, what computers can do. Searle said this basically in his Chinese room thought experiment. There's lots of people that make this point, but we tend to forget it, especially because we're such, can I say it, suckers for convincing texts. We just fall for it like a ton of bricks. There's no one there. So there's a question that we have now, I think. If this is what AI presents us with, if this is what AI sets as a standard to which we can compare ourselves to, then what exactly do we do with the differences that we notice? And why, for instance, are we so keen on intelligence? If you do a self-diagnosis as Homo sapiens, just as a human species, you know, we pride ourselves on being the smartest on the planet, and the dolphins don't argue with us, so we can continue believing it. Is it really intelligence that we lack? Why exactly are we trying to increase intelligence so much in artificial systems? What's the driving force, apart from the economic incentives that I understand, of course, but in terms of a collective self-diagnosis, know thyself? Knowing thyself also means knowing what you maybe don't like about yourself, what should be improved. As a collective self-diagnosis for Homo sapiens, AI is a very interesting mirror, I think. So this is a very old book, 50s, from Mortimer Adler. He was one of the people behind the Great Book series. Maybe some of you might remember, very interesting project from the 50s. And he has a chapter in this book called Angelistic Ethics. And he says there, most of us are aware that we have done things we ought not to have done and have failed to do things we ought to have done. I'm not asking for hands, especially not because this is recorded, but I plead guilty, okay? And I'm on record, so too bad. The best explanation of why this is so consists in recognizing that in human conduct, as contrasted with the action of angels, knowing what is really good for oneself, and so knowing what one ought to do, does not suffice to produce conduct that aims at what is really good. This is a problem that Homo sapiens have. If we do a collective self-diagnosis, we shouldn't be working on increasing intelligence. We should be working on increasing our ethical behavior. And we see this all the time. If you look at United Nations Sustainable Development Goals, the list is pretty basic, actually. You don't need to be a genius to understand that no poverty and zero hunger in the long run would be better for everyone. Not just for the people that don't suffer, but also for the people that suffer, but also for the people that don't suffer. Peace, justice, and strong institutions. It's still there on the list. So I checked a little bit. If you look at the 20th century, taking it a little bit long, starting 1860, the list of armed conflicts is endless. This is incomplete. The casualties are numbing, mind-bogglingly high. I didn't even try to calculate the total. Here, 11 million just in China. And the list goes on. It stops at 2018. I don't need to remind you what's happening now. Why are we so interested in intelligence? It's not because we're, you know, anyone is too stupid to understand the human rights. Are they so complicated to understand? I don't believe it's a problem of intelligence. The problem is applying it consistently. That's the problem of Homo sapiens. You know, there is something that we need to develop in ourselves, and that is a capacity to feel and act empathically. We understand that it would be better, we're just not doing it. That's the major challenge I think that AI presents. We're banking on the wrong horse, so to speak. Betting on the wrong horse. What we need, what technology should be doing, what we need to develop in order to improve Homo sapiens is not create more intelligence, but create moral crutches. A kind of walking stick in the ethical domain that helps us to behave more consistently, empathically. We don't need better ethical codes. They're very basic and they're very correct. There's nothing wrong with the ethical codes of human rights or something. We just need to behave in ways that are consistent with this. So in saying this, I'm not saying that AI is a bad thing. I work at an AI department, you know, I like my job. But there is something wrong with our fascination with ever increasing intelligence, while the real repairments to Homo sapiens, the real comparison that we should make, is actually in a different domain. It's in consistent ethical behavior. So funnily enough, and I'm closing now, AI teaches us a very important lesson. It's not what distinguishes us from animals, our superior intelligence, we like to believe, that is so crucial. It's actually what we share with animals. It's the empathy, the capacity to empathy. That's what we should be looking at much more if we want to understand ourselves. It's the animal cognition inside of us. So there's a lot of comparisons you can make. We can look at angels, we can look at robots, we can look at exemplary human beings. There, I think, lies the biggest challenge. And angels, in that sense, still have a lot of promise in helping us to find the right path for further scientific research. Thank you.
Thank you, Pim. It's time for short Q&A. Staat hij aan? Okay, yeah. Yeah, very fascinating talk, and I really like that you latched on to my presentation without knowing. So perhaps there was some intelligence between us or some empathy. I recently read that GPT is very good in BSing, yeah, bullshitting.
Yes.
Perhaps that's a great, but it's very convincing. So I was curious, are there any questions here in the room? And I'll pass on the mic and then you can ask the question and Pim will answer it. So.
Thank you. Yeah, I wanted to ask you about the idea that failures of intelligence are not a significant part of why we fail morally. So I agree that there's a big problem of motivation, right? That there's this gap between what we know we should do and what we actually do. But there also seem to be many cases where, and maybe I just hang out with a worse class of people than you, people actually disagree about like human rights existing, or that people should have free access to healthcare, right? I mean, I'm an American, so we believe all kinds of crazy things. And that does seem to be not only a failure of empathy, but also there are all kinds of biases at work in their thinking that maybe do have to do with intelligence.
Yeah, I'm not so sure it has to do with intelligence. I think it has to do with certain psychological mechanisms that are in need of further studying. So one, for instance, that is really crucial is in-group, out-group distinctions. Everybody is for healthcare for others, as long as they're among us, you know, like us. It's the others, the bad people, or not even the people. I think Trump at some point said about Mexican immigrants, they're animals. You know, that's the first thing you do in order to exclude certain people of the human rights. They don't deserve it because they're not supposed to be human. So it's these kind of mechanisms like in-group, out-group distinctions, or another one, willful blindness. You know that it's not so wise to go to a conference by airplane, and how important is my talk anyway, you know, but at the moment that I'm buying the ticket or accepting the invitation, I sort of conveniently forget. And then next week I will talk again about the, you know, the disasters and global heating that are approaching, and that we all need to be, you know, if you look through in the city, there's all these outdoor heating. And there's people sitting there talking about the planet, you know. So willful blindness is also something that is really an interesting phenomenon in humans. So I think once you see it, you know it's not so difficult to understand. It's not the cognitive complexity of the challenge. It's more like the mechanisms we apparently have, probably evolutionary in nature, that we need to understand better in order to develop the moral crutches that we need. Hannah Arendt, the banality of evil. It's all those kind of principles that we need to investigate better. And that for me is something different than genuine intelligence.
Do you think we are making moral progress already? Because I think we believe we are living in ethical times. And do you think do we have these crutches already, or are we staying on the same level, let's say 100 years ago?
No, I don't think we're making that much ethical progress. I think Gandhi, for instance, said when it was asked to him about Western civilization that he thought it was an excellent idea. You know, if you look at the history, the recent history and the wars is just one example. Also in Europe, I mean, where do we really stand? It's easy to say like, okay, so, you know, we make progress in relation to hunger and poverty. This is mainly because of the economical development in China, that progress is there and it makes a difference because there's so many people involved. But actual fairness in sharing, you know, Europe is building a wall these days to keep the immigrants out. We're causing economical damage through climate change in Africa. And we're seeing it not as our responsibility, and the people have to stay there. So in that sense, I think this in-group, out-group mechanism still is very much in operation.
All right. Any other? Yeah.
Hi, something you said really struck me strongly, and you said it in passing, that you wouldn't blame your students for using AI on an exam. And the reason I'm bringing that up is because since we're discussing ethics and morals, and we talk about the role of AI in everyday life, could you expand on that a bit more?
Thanks. Yeah, so, okay, I tell them that they shouldn't. I tell them explicitly why we're doing oral exams, and that, you know, cheating on exams by using other author of a text that you present as being your own is fraud, right? At the same time, I don't want to be sounding like a saint, because I'm not. I am very human. These days it's improving a little bit, but when I was 20, I was a disaster. So I think in that sense, it's just acknowledging that from an ethical perspective, defective wiring is also in me. You know, we have to, so this know thyself is a very deep question, right? And I think it really means what you don't like about yourself first and foremost. And you have to acknowledge that. So this is my way of acknowledging that I understand that the temptation to use something like GPT-3 for a philosophy exam, I would find it irresistible. I would want to see how it works and whether it works. That's not good. I'm not proud of it, but it is who I am. And I think in a way, this is who we collectively are. If we can get away with it, it's really tempting. And so if we check where we should do our research, both from a neuroscience perspective and from an AI perspective to build these moral questions, that's where we have to go, not to intelligence. It's a priority setting, I think. So that's why how I meant it anyway.
Okay, there's another question.
Thank you, Pim. You make some things so clear that it's impossible to unsee afterwards. I'm very curious about the intersection between theology/religion and computer science, because, well, as theologians, I think we can learn a lot from just looking at AI, as you said, and we can see what we are not and maybe what is important about our humanity. And there is some exercise in that, and I think I'll talk a little bit about that later. But I'm very curious from your perspective as a computer scientist and philosopher, what are, because you quoted Aquinas, what are the kind of theological discourses that you find useful in your reflection and framing of AI, and what are those that did not work?
Well, to be perfectly honest, I am just starting, like I said, you know, from this perspective, theology, the history of the church, the history of thinking about humans from a transcendent perspective, for me now starts making much more sense than it did when I was a student in philosophy. So I read some medieval texts. I kind of understood the talk about representationalism and stuff like that, you know, because it fitted with the kind of technical psychosemantics, Jerry Fowler kind of times in which I read that stuff. But the bigger picture was not so clear to me. And now looking at this sort of, and so it's, for me, it started actually by being seriously puzzled by our fascination with our intelligence. We're already the best, we think, and we just want to improve what we're already better at, whereas the other deficits are so glaringly obvious. And it's only now that I start going back towards text and comparisons with angels and stuff like that, in order to see how much work already has been done. But I'm not knowledgeable enough at this point, but I hope to work on this for the next couple of years, at least, probably the rest of my life, I guess, to understand that better. So I cannot answer your question, but I would like to be able to answer that question, but that's in the future.
All right, any more questions? Yeah.
Thank you. So at the end of your talk, it seems that you make quite a distinction between intelligence and ethics, and intelligence and empathy as well. Well, a lot of research in emotions also shows that emotions are very much fed by cognition and intelligence. And there are a lot of theories on ethics that also have a big role on intelligence. So I'm wondering about kind of the interaction between intelligence and ethics, and intelligence and emotions.
An excellent question. And I think they're not completely separate. That's the simple answer. Of course, there's mutual interaction. However, as we all know, and there's some neuroscientific evidence for this as well, that, you know, like say dorsolateral prefrontal cortex, alternative planning activities, that's one system. Limbic system, emotion related, that's another. You know, the amygdala in relation to fear. Fear is a very important mechanism in group, out group distinctions. You just scare people of someone and then they will immediately distance themselves from it. So that's a system that is evolutionary older, quite shielded, and simply talking, thinking is not going to change your limbic system activity very much. So there's a neuroscientific understanding of why simply telling people the right principles is not working. You do that by habit creation, virtue ethics, you go in that direction. And that makes sense if you look at the brain structure. I'm really simplifying stuff now, but for sake of brevity. So yes, these systems are interactive. Do you know the work of Jonathan Haidt? So he speaks of moral taste buds, for instance. It's like we taste food and we go yuck or yum. There's also moral taste buds, and the in-group, out-group is one of them. It's very strong. And you don't argue someone into a new taste. A new taste is acquired. You have to do this over time and learn to appreciate. That's a sort of training of a limbic system in a different direction that requires continuous practice, not argumentation. He has a wonderful paper, or at least a very good title, about the dog and the tail. He says, if you give people arguments to change their ethical position, you're basically trying to wag a dog's tail in order to make it happy. Well, don't try. It's not going to work. You know, rather the opposite. So that's something. So the moral crutches require neuroscience and AI. It requires a deep self-understanding and then building the kind of structures that can help us. So that's the super ethics paper that I wrote together with Julio. It's a little bit making a call for that. And it's funny in a way. So there's fitness apps. There's millions of them. And it's $1 billion industry. You can have them on all sorts and you can choose whatever you want to, perfectly amenable for you. You know, you can set the parameters, etc. Where's the moral fitness app? I found in the App Store, I searched for it, one, and it was a disaster. It tried to help me understand human rights. Yeah, no, thanks, I can do that. It's just that I'm not capable of behaving consistently according to those human rights. Because in a way, of course, human rights are my obligations to other people. In that sense, I think also, by the way, human rights is a misnomer. It's human obligations, not human rights. We think I have rights. No, my rights are your obligations and your rights are mine. So they're obligations actually, but I don't stick to it. So that's something, and I don't think there's a solution in terms of apps. The moral crutches are not going to be apps in essence, but it's just to make the comparison. There's so much stuff about fitness, nothing in terms of morality. Whereas there we need to learn and develop the habits in the same way that you need fitness habits. You know, once running it doesn't work, you have to go every day. And building that habit is difficult. Same for ethics.
All right, so we have time for 2 more quick questions then. Yeah. Start with you.
Okay. On building ethics, someone said it's like building better software in your head. It's a kind of a new form of reductionism. If you just say, well, a moral stance is nothing more than a very complex moral neural state of mind. What do you do against reductionism, the constant quest for it?
Yeah. Well, I don't believe in simple reductionism. But as a scientist, I would like to be able to understand myself, us, Homo sapiens, in terms of the lawful interaction between physical particles. I want to go as far as I can with that, which is not the same as claiming that we can explain everything. I just don't know. And I just mentioned a few concepts like consciousness, awareness, sentience, you know, where I think we're dismally bad, the will. So I don't think anyone who claims that we know now that scientific materialism is true is correct. We just don't know. But at least trying to understand what I don't understand and what I cannot explain is helping me scientifically in setting a research agenda that I think we need. So I believe in a kind of methodological reductionism as an approach, because then at least I'm sure I can understand it. Well, with the limitations that I have, of course. And going to the other side, dualism, is not really helping me intellectually. I want to understand. So that's my problem with I would feel it as giving up too soon. But at the same time, I want to acknowledge the problems. And I looked at emergence and downward causation, etc. Epistemologically, totally correct. When I try to interpret it ontologically, emergence and downward causation, I don't see it. So there's something to be explained there too. Yeah, that's where I stand.
All right, we have a question here from Hans.
Thank you. I want to return to the analogy with angels and AI. Maybe I was thinking maybe a better analogy is demonology, because the medievals and the Renaissance thinkers, they wrote a lot on demons. They were highly intelligent.
Yes.
They could predict the future,
Yes.
and you could make use of it, but you should be very, very careful because they lack a moral compass, sorry, and they lack any connection to truth or God. And that got me thinking to the connection to AI and ethics. We can know human rights. We can know, for example, we should avoid wars, but AI can help us in getting information, like what is the best foreign policy to avoid wars in 10 years' time? What are the implications of wars? How do wars impact people? So AI can help a lot on ethical grounds there. Yeah, it seems.
Yeah, excellent points. First one, I agree. My next on the to-do list topic is check especially the fallen angels, if you like. You know, that's fascinating. There's a beautiful play by Joost van der Vondel, Lucifer. That is really great, and I wanted to quote, but yeah, there's so much stuff I couldn't do it. But there's very interesting stuff there. Yeah, so that's really high on my to-do list. So I totally agree. The second question, yes, we can use AI for, let's say, negotiations to find a collective optimum. The question here too is, why is there so much money going towards AI and neuromarketing, by the way, you know, that happens too a lot, in order to make people click on advertisements, and so little money towards that type of AI? That says something about us, you know. There's a very funny phenomenon in AI that, you know, there was a quote many years ago already, that the sharpest minds of our generation are now going to work on making people click on advertisements or keep them hooked on Tinder or TikTok, you know, watching cat movies or worse. That's what the sharpest minds of our generation are doing these days. That's a choice, you know. So I agree. Same with the moral crutches. I think AI can help in building moral crutches. The question is, why don't we build it that much? So there's the question I'm raising, I think, is prior to the development of technology. Of course, you can use AI for good, and it happens sometimes. I don't want to be completely negative here. That would not be fair, but it's a small minority. Simply put, it doesn't get funded. So that's where the problem is, I think.
Yeah, one interesting observation about negotiations. Facebook launched last week is something called Cicero. That's AI that can collaborate and negotiate with you. And so it can play a game which is called diplomacy. So in a way, they're investing in it.
No, I know. Katelijn Jonker, a colleague of mine who's now at TU Delft, worked on a pocket negotiator already 15 years ago. So there is work in that area, but it's not like, you know, let's say the commercial.
Yeah, but the fun thing is it's done by Facebook research. So we have one more question.
Not to trust it.
Well,
thank you. You made very clear your point about AI being non-sentient, and us lacking any kind of understanding of how consciousness arises in humans and in biological creatures. But let's just, for the sake of the thought experiment, assume that in the future, we will find a way to either by biosynthesizing something, let's say that we didn't have that problem on the table anymore. What then about the possibility of AI developing its own form of religiosity or spirituality? What do you think? And how should we take, if we saw algorithms claiming that, how should we deal with that kind of claim?
Well, okay, going there, which is a big if, because it's also something we don't understand about ourselves. So that's not going to be easy to implement. It's not just faster machines that will do it. You know, we need fundamental principled insights that we're currently lacking. But taking that for granted for a second, it would change the field completely. Of course, then machines would have rights. If they're sentient, you have rights, I think, like animals should have, and to a certain degree have already, and like humans have. Sentience is about rights. What nature their cognition would be, and whether something like religion would develop, is an important question. I mean, I think it's fair to say that religion is a universal phenomenon. amongst human beings. I think even though people like me work hard not to be, because I like to understand, I can totally understand the religious experience. And I don't think I'm immune to that even. So perhaps if it would be a human type of intelligence, it would seem reasonable to extrapolate that they would develop something like that too. On the other hand, if it would be really an arcane kind of intelligence, in ways that we cannot foresee, and the possibility, of course, is there, especially with these self-learning kind of systems, who knows what they will believe. There's a very nice cartoon that a human being is talking to a computer, and he's saying, after doing a kind of Turing test, you know, like, well, you're not really there yet, you know, you're not like me. And then the machine says, why would I like to be like you? And that could apply to these intelligences that are self-developing at some point too.